Alright, so in the previous video we found the eigenvalues for the example 8. Okay, so let's now find the eigenvector. So the matrix A is actually 1, negative 1, 4. This is what we had. 3, 2, negative 1, 2, 1, negative 1. Okay, alright, so first take the first eigenvalue, lambda 1 is equal to 1. Find A minus lambda I. So I'm going to do that fast. So that means A minus lambda is 1. So A minus I, which will be 0, negative 1, 4, 3, 1, negative 1. You subtract identity from this matrix A, 2, 1, negative 2. So this is the A minus I. Okay. Now pause it and try to find the eigenvector by yourself. 0, negative 1, 4, 3, 1, negative 1, 2, 1, negative 2 times K1, K2, K3 is equal to 0, 0, 0. Okay, so let's use the Gaussian elimination. 0, negative 1, 4, 3, 1, negative 1, 2, 1, negative 2, 0, 0, 0. Okay, alright, so what can we do? Here, well, the first pivot position is 0. That's a problem. So let's swap a row. How about if we swap R3 and R1? So let's swap R3 and R1. So what we get is 2, 1, negative 2, 0. 3, 1, negative 1, 0 here. 0, negative 1, 4, 0. Okay. So this is what we get. Alright. So now we want to make this 3, 0. But here having 2 is really uncomfortable, right? So let's divide the first row by 2 to make that part 1, because then we can get rid of this 3. 1 here, half here, negative 1, 0. So we couldn't afford that. We have we cannot skip the part that we get a fraction. Okay, 3, 1, negative 1, 0, 0, negative 1, 4, 0. Alright, so now what we do is, well, let's multiply the first row by negative 3 and add it to the second row so that we can cancel out this term. So what we get is 1 half negative 1, 0. Here 0, negative 3 plus 3 is 0. Now here half multiplied by negative 3 is negative 3 half plus 1 is negative half here. Okay, here negative 1 times negative 3 is 3. 3 plus negative 1 is here 2, right? Right. Here 0, negative 1, 4, 0. Okay. So now what we can do is really, now we go to the second pivot position. This is negative half. So if you want to create 0 out of at the negative half, what you can do is you can multiply the second row by 2 and add it to the negative 2 and add it to the third row, right? So if you multiply negative half by negative 2, it will be 1. 1 plus negative 1 will be 0. So this will be like 1 half negative 1, 0. Here 0, negative half 2, 0. So here it will be 0, 0. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Okay, so that's this. So we are done with the Gaussian elimination. Let's write the equation. So before the matrix form is 1 half negative 1, 0, negative half 2, 0, 0, 0 times K1, K2, K3, little k's equal to the right hand side 0 matrix. Okay, so let's write out the equation. K1 minus K1 plus half K2 minus K3 is equal to 0. Minus half K2 plus 2K3 is equal to 0. Okay, this is a little bit complicated, right? It's okay. So let's write the second equation. This equation will be 2K3 is equal to K2 over 2. So K3 is, if you divide by 2, K2 over 4. Alright, so this is this. From here we can see K1 is negative K2 over 2 plus K3. So this is K1. Alright, so let's see. What did you choose for K3? K2. Because here it's easy to choose K2. What is the smartest choice for K2? K2 will be 4, so that we get 1 for K3, right? So 4 K3 will be 1. Now what is K1? K1 is negative. K2 is 4. 4 over 2 is negative 2. Plus K3 is 1. Negative 2 plus 1 is negative 1. So this is the eigenvector for the eigenvalue 1. Alright, so we still have a long way to go. All right. Okay. All right. So let's resume work. So this is correct. So now we move on to the second eigenvalue. So the second eigenvalue is -2. So the matrix A again is 1, -1, 4, 3, 2, -1, 2, 1, -1. So you want to find A minus lambda I. So that means A minus -2i, which is A plus 2y, right? So A plus 2y will be, excuse me, so we can find that quickly. So let me write it quickly. You should pause and do this, okay? So here 3, -1, 4, 3, 4, -1, 2, 1, 1. So this is A plus 2y. Now you want to solve this equation where you want to find these little k1s, right? Little k's. All right, here we definitely need to use the Gaussian elimination. So let's use the Gaussian elimination. 3, -1, 4, 3, 4, -1, 2, 1, 1, 0, 0, 0. So what would you do? So let's look at the first pivot position. All right, so this is also a little bit complicated, all lots of fractions, right? Unfortunately. So, well, we cannot avoid that. Well, we can multiply the first row by -1 and add it to the second row. Okay, so that will give us 3, -1, 4, 0. Here this will be 0, -3 plus 3, right? Here this is 0. Here -1 plus -1, -1 times -1 is 1. 1 plus 4 is here 5. Here -4 plus -1 is -5 here. Okay. So now to create 0 at 2, what I can do is divide R1 by 3, multiply by -2. If you divide this first term by 3, it will be 1. Now you multiply it by -2, so that when you add with this 2, you get 0. Okay. So here it will be 0. So if you multiply you will divide -1 by 3 and multiply by -2 will be 2/3. 2/3 plus 1 will be 5/3, right? All right. So you divide 4 by 3 and multiply by -2 will be -8. -8/3 plus 1 will be -5/3. Okay. So this is the third row. All right, so that was a little bit lots of fractions. Okay, do it slowly. Okay, I'm doing it fast. Okay, all right. Now before go hand, I would like to get rid of fractions. So I will multiply the third row by 3 so that I get rid of fractions. Then life will become easy. Okay, trust me. So 0, 5, -5, 0. Here 0. If you multiply by 3, 3 cancel out. 5. -5, 0, right? Now the second pivot position is 5, so let him be 5, don't make it 1. How do you make 5 0? So you subtract second row by the third row, right? So what you get is 3, -1, 4, 0, 0, 5, -5, 0. Here 0, 5 minus 5 is 0, -5 minus -5 is 0. So, okay, at least we are done now. All right, so we get the new metric equation 3, -1, 4, 0, 5, -5, 0, 0, 0 times little k1, little k2, little k3 is equal to 0, 0, 0. So now let's write down the equations. Okay, so 3k1 minus k2 plus 4k3 is equal to 0. 5k2 minus 5k3 is equal to 0. So those are the two equations. So from the second equation we get 5k2 is 5k3. That means k2 is k3. Now from the first equation we get 3k1 is k2 minus 4k3. Alright, so k2 is equal to k3. What would you choose for k3? 1, right? k3 1, k2 1. Okay, let's find k1. 3k1 is k2 1 minus 4. Here -3. So 3k1 is -3. So k1 is -3/3 is -1. So this is the second eigenvector. All right. So now I'm gonna find the third eigenvector. So lambda 3 is equal to 3, but the eigenvector I'm not going to do that in this video. Okay, this new eigenvector will be 1, 2, 1. Try to do it by yourself, okay? And the process is in the note, okay? Alright, so then, well, let's write the general solution. That is what we should do at the end of the day. So the first eigenvalue was 1. The eigenvector was negative 1, 4, 1. Second eigenvalue was negative 2. The eigenvector was negative 1, 1. Third eigenvalue was 3. The eigenvector was 1, 2, 1. Okay, I didn't find this one, but you can follow the book. Okay, the note. So the general solution is x1 is negative 1, 4, 1. The associated eigenvector is 1. Eigenvalue is 1. So e to the 1t, e to the t. x2 is negative 1, 1, 1. E to the negative 2t. x3 is 1, 2, 1. E to the 3t. Alright, so then the general solution is C1 arbitrary constant negative 1, 4, 1 e to the t plus C2 negative 1, 1 e to the negative 2t plus C3 1, 2, 1 e to the 3t. So this is the general solution for the differential equation. Okay, it was a big one. I agree that this was a hard question because the Gaussian elimination was not easy, but it is what it is. Okay, all right, thank you.